Hello everyone, I hope you are doing well, you are safe and learning a lot. So we are back with one more topic and the topic of the day is design thinking for mechanical engineering people and we'll see what is design thinking, what are the other steps which are involved in design thinking and throughout this video we'll be looking at topics like what is design engineering, uh, what does product life cycle mean, what triggers to a new design, what is a design solution, what are different steps involved in design, what is a real concurrent engineering, what are technical reviews and how they take place in the organization, what is a typical organization structure looks like. So these are the topics we'll be looking at. So, if when we are talking about design engineering, you take a moment to observe your surrounding. There are certain things like cupboard is there. There are cars. There are telephones. There are bicycles. There are laptops. There are windows. There are extension boxes. Everything around you is a technological creativity. It has not miraculously appeared, but it has taken its own time to evolve, uh, originated from human minds, and it took time to develop its uh, own product. So, engineering is the creative process of turning an abstract idea into a physical representation that is a product or a system, etc. And what distinguishes design engineers from painters, poets, or sculptors is that engineers apply their creative energies to produce products or systems that meet human need. And this creative act is called as design. So the basic fundamental is what human need, and that is being developed, that is being brought to life. And the whole process of putting that is called as design. Mechanical design means the design of components and systems of mechanical in nature, that is, machine, product, structure, devices, or instruments. And for most of the parts, we use mathematics, we use material engineering, we use uh, mechanics, science, etc. Additionally, we use engineering graphics, which has the ability to communicate the things to each other. And there is no language barrier for engineering graphics, it is a universal language. So, when we talk about mechanical engineering design, we take all the things which are there in mechanical designs, but we also add thermal fluids, heat transfer science, etc., finite element analysis, and all that stuff inside. And what we get is a combination of all is called as mechanical engineering design. So, what is engineering design? So most of the engineering devices can be classified as inventions, devices or systems that are created by human effort and did not exist before, or they are just improvements over existing devices or systems. So inventions, and as we spoke earlier, the inventions or designs, they have not appeared from somewhere, or they have not appeared suddenly. So it has taken its own sweet time. It has taken a step-by-step methodology, and that's how it has come to life. We have to remember one thing, that engineers are the problem solvers. Design problems are open-ended questions. They are not a close-ended question. So open-ended question is they have multiple answers to it. There are multiple solutions to a single problem. And design problems have vague description, but analysis problem is point on or bank on. So we can discuss that. I have put two sentences over here. We can see what is a design problem and what is an analysis problem. So determine the maximum height of a snowball given an initial velocity and release height. So it is a very bang on statement that we have to find something and all the conditions are given out there. So that is nothing but an analysis problem. So it is a question, mathematical solution is there, and there is only one solution. So 2 plus 1 has only one solution. It is only 3. No, not 4, not 2, or not 0. But if you look at the second sentence, design a device to launch 1 pound snowball to a height of at least 160 feet. It doesn't have a unique solution. It has multiple solutions, and we have to choose the best solution out of it to work out the given problem. So design problem is an iterative process. So we have a design problem, we find the solution for it, we check for its feasibility, its cost, its safety, validation, we test it, and then we find the optimum solution out of the available solutions. And then we go for implementation. If we do not find the optimum solution, we go back to the previous process, we find the answer, and then we move ahead. So that's why it is an iterative process. It is not a single line process. So product life cycle is nothing but we launch a new product into market, how it grows, and later on what happens to a product. So for example, let us say we have launched a car, a company has launched a car into market. In the introduction time, we do all the development, we do all the background checks, we do all the benchmarking, all that sort of thing what is being done by the company comes under introduction. And during the introduction phase, or during the pre-workout phase, we are not, the company is not making profit. It is very, we are investing, we are, uh, finding the solutions and all that sort of things. Once we introduce the product, the process is very slow. We have to do marketing, we have to reach out to people to tell them that okay, we have a new product. All that sort of thing happens in the introduction phase. And then at that time we have very minimal sale. Now as time progresses, as people spread the word about the product that okay, this car is very good, it has good mileage, it has safety bags, and it has some features which are not there in this kind of a segment car, all that sort of things spread into market, and that's how the growth of the product starts. What happens is after a year or two, or maybe like 3 4 years, the product reaches its maturity states. So maturity state is either there is a competitive product in the market, or all the improvements which were required in that particular product have been implemented by the company, and it is time to introduce a new product, a successor of this current product into the market. So we have reached the maturity stage of the product, and from that point, the decline stage of the product starts. And in between maturity and decline, generally company goes into introducing a new product or starting to build all the pre-workout for the new product. And most of the times, at least in the decline phase of the product, companies launch their new product. So that's how the overall life cycle of the product looks like. So the topics which we are covering here, they themselves has its own set of discussion, but we are looking at a broader topic which is called design thinking. And if you want that I should discuss more on a particular topic, do drop them in the comments. We will put those topics in the upcoming videos. So what triggers a new design? Okay, we know that new design how we are going to do a new design, all that sort of things we are discussing. But what triggers to a new design? The first and the important thing is customer demand or the market need. Is there any customer demand for it? Is there any market need for it? For example, a new car, is there any customer demand? That okay, between 5 to 10 lakh, there should be some kind of a demand which is there in the customer or in the market, and that we are catering to. Okay, so it is time to introduce a new product. Let us say company has established a series of successful products over the time, and if it wants to maintain a consistent stream of sales or grow over the time, we have to introduce new designs in a periodic time. So a new product which is not a part of the company's portfolio, for example, an electric car, which is not part of the company's portfolio. There have been cars of diesel and petrol, but electric car, because it is a need of the time and the market is asking for it. Uh, as we discussed in the earlier stage, that previous product is becoming obsolete. That's why a company needs a new product. There are better products than our company. The competitor has a better product, and we have got to know that from market survey, customer feedbacks, benchmarking, etc. So that is a need of a new product. When there is a market opportunity for sale, and we already have a product, and from historical data, we got to know that this product is very good, but it needs some improvement in the product, which will make it best. So that all things, these are not limited to, but most of the things are being covered, which will trigger a new design. Now we have known that okay, there is a need of new design, but what is a design engineering solution? We have to find the solution for that to cater the need of the design. So a good solution of design problems require a methodology, a process, and probability that number of methodologies equal to number of engineering workers to the problem. So it may be like there are like 5, 6 methodologies to a single problem. So it means that some of the times there are 5, 6 engineers who are working on the same problem. And there is a step-by-step process for design solution, either a new or a evolving design, whatever it may be, it has a step-by-step process. What is that process? There are different steps which we will see here. So the first step is to understand the need. We have to understand what is the need in the market. Second is we have to define the problem. We will discuss in details, but defining a problem is a very, very crucial part. We have to gather information about the problem. We have to generate various concepts that okay, for this particular design, how many design solutions we can find out. Then we have to select one of the best the concepts. We have to finalize the design. Then we will do a detailed design of the real design work will go into it. Analysis will be done. Then we'll do a prototyping, we'll do testing, we'll do test and validation. And at the last, we go for production and manufacturing. We do all the life cycle maintenance activities for that product. We will set up a whole life cycle of it, and then the final product comes into life. Now, understanding the need. First and most important step of design process is to understand the need. We have to fully understand what is the need of uh, the design. You have to understand what the user, the client, the customer is asking for. For example, if a car goes to a mechanic, what the user says, my car steering is off center. So when I am driving straight, my steering is a bit off, turn to left or either right. So what does it tell the mechanic? Okay, so it requires the wheel alignment. So that is understanding the need. In a food packing machine, it is making an undesirable sound, and service engineer has come. So he knows that okay, there must be some vibrations or there are some loose parts which are causing this kind of vibration, and that is why the sound is coming. So we have to be a very good listener to understand the need. Then we have to define the problem. It is the most critical. It can make or break the whole design. So for instance, if the need is for cleaner, more air in the car, the problem might be that the reducing dust from the AC filter, reducing the obstacles in between might solve the problem. The problem definition must include all the specifications of the product to be designed. And generally, the problem statement must answer three questions: what is the problem or the need? Who has the problem or the need? And why it is important to solve that problem. So, if you read any journal papers, there is a problem statement which is marked top right, top on the top. So it defines that why this paper has been written. So in the same way, you have to define the problem. So example of problem definition: the manufacturing and assembly process for product XYZ to be as efficient as possible, or design a vehicle which can maneuver in indoor activities or indoor environment. The vehicle will be operated by a remote control and must be able to travel all those sort of things. There are needs which are bigger. So we know the no problem. We have to define what is the problem and why it is needed to be solved. So here we see that vehicle which can maneuver in outdoor environment. So that is the main. So it is seen that vehicle which can maneuver in an outdoor environment is the main problem, and why it is needed to solve the problem, and what are the needs in that. Is it should travel the given speed, should climb 5 inches high stairs at speed of 2 feet per second. So all those things are being given there. So we have to segregate, we have to break the things, and we have to define it. The general design considerations might be uh, so these are the general design considerations. They are not in particular order from high to low to high, but it has strength, cost, flexibility, stiffness, wearability, then styling, ergonomics, volume. So all these things has to be addressed for that particular product. The next stage is information gathering. It is a never-ending process for a design engineer. It is an ongoing process. We have to gather all the information regarding the product. So who has the product? What is the history of the product? What is the competitor doing with the product? What is the performance of the product? We may have to break down the information. We have to break down the product to gather the information. But a general source of information might be: you have engineering journals, we have textbooks, we have referral books, there are design documents which are standard documents. There is a lot of literature available around the world. There are case studies, there are people, there are technical handbooks, there are patents, there are technical reports, there are benchmarking, and there is national international standard. So all those sort of things we have to study. Now the next thing is concept generation. Now we know what is need. We have understood the problem. We have gathered all the information. Now the thing is we have to generate concepts, as many concepts as we can. So generating new ideas that may solve the problem. So it is a creative step in all the engineering steps. So we start with an existing, some of the times we start with the existing solution. We tear them apart, find out what is wrong with those solutions, and we focus on improving their weaknesses. That's how the first step. Some of the general approach to the concept generation are adaptation. We adapt, which is what is there in the market. We do analogy. We do area thinking. We do brainstorming. We do involvement. We do functional synthesis. All the sort of things we do. Brainstorming is nothing but we sit together, we throw out ideas, and we note them down. There is no bad or good idea. There are ideas which we discuss. Area thinking is nothing but we restrict ourselves to a particular area of the subject and we do discussion around that particular area. So that's what it is. So there are different tools like Trace and all those to discuss to generate new concepts. So it is a 35 by 35 matrix which is there, and it will give you a guideline of a base to start with new designs. So this is like one of the examples. This is one of the papers which I have published in an international journal. So the need was to generate a multi-purpose transformable chair. So there are few concepts which you can see, and there is something called as bug matrix or concept screening, which can be used to drill down the concepts so that we can choose the best concept. We compare the concepts with each other so that we get good and bad things about it, and then we go to the final product. Now, design communication. Once all this being done, there is a need to design to communicate all these things. There are types of communications like written communication, oral communication, graphical communication. And in nowadays we work in a global environment. So all those things, which whatever things we are doing, they have to be communicated, they have to be documented. Because if we don't document it, we don't communicate it, there will be a communication gap, and that may lead to a very disastrous situation at the end of the product launch. So that uh, situation we don't want to be in. Then the next step is, now we have finalized the design, we from all the concepts. Now we go for a detailed design and analysis with all the engineering principles, with all the technical knowledge what the engineers have. We build the mathematical models which will accurately simulate the physical world. We get down all the information we have, and we design a new product. Now, this topic itself has many, many things to be discussed. So, but the time, the video will be too long if we just go on discussing about all those things. So, I'll not go in detail with it. But what we generally do is we create a mathematical model, we go for analysis, we analyze it, we get all the results from it. We will study the result, we'll analyze the results, and we'll say, okay, this product is working the given need or no. So that's how the things will happen. It will involve finite element analysis, computational fluid dynamics, life cycle analysis, all those things will be done. There is like hand calculations will be done, or there are some internal company tools which are available. We'll use them, and we will do our calculation. So this is one of the examples of FEA calculations. Once all this detailed designing and analysis has been done, what we do is prototyping and testing. What is a prototype? Prototype is nothing but we make. Now we have made the couple of the mathematical models. Now we build a physical model out of it, either by using 3D printing or actual traditional manufacturing processes. We manufacture that product, or we build that product and we test it, so that we'll get the results. Either we build the whole product, or we build a part of the product and we put it into the existing product, so that we'll get to know the performance of the product. So we do testing, we do construction, we do manufacturing of this prototyping, and all the results once we gather down the line, we will give feedback to the design engineering team, and now they will work upon it if there are any uh, drawbacks in the product. So that's it. It is an iterative process. It is not a single line. It is a front and back, front and back. We give the information, we get the feedback, we give the information, we work upon. That's how it is being done. So when you go for an auto expo, what you see is a concept car. It is not an actual car, but it is a concept car. Then you see, like on the right hand side, if you see, there is a concept of backpacks, like 1, 2, 3, 4, 5. So they have different functionalities, different style, different look, and maybe different feel of it. Again, if you look at or look around the things, there are people who do only prototyping, and there are tons of products for prototyping. Then once we finalize the prototype, what we do is testing. For example, now in 2022, F1 is going to launch a new car. Before launching the new car, what they have done is they have done all the process what we have discussed, and they have built a model. Now they have built a scaled down model, and they have put into a wind tunnel, and they have tested uh, all the things which are required. They have tested the stability, they have tested the ergonomics, they have tested the aerodynamics, everything they have tested. Once they are done with it, all the testing is done, they have got the results, they know where to improve. Then they launched the 1-to-1 scale car. Now, it is not. It is said that the people have driven the car, but we'll get to know as on when we come near 2021. And because in 2022 they are going to launch the new car, so that's how the testing usually is being done. But there are different applications used throughout this. So there are applications like for CAD modeling. There are applications for CAM programming for manufacturing. There are applications for analysis. So on the left hand side, what you are looking is all the uh, CAD modeling. So there are tons of other softwares as well, which I have not included. But these are some of the famous softwares. So one is Siemens NX or UG, what is traditionally being called AutoCAD, then SolidWorks, Creo, CATIA, then Inventors, Autodesk's Inventor. All those softwares are usually being used, widely being used for CAD modeling. Then there are softwares like Hypermail, Fusion 360, SolidEdge, Mastercam, SolidCam, NX, CAM, RhinoCam, eSpirit, Vericut. All those things are CAM softwares which are used for programming of manufacturing programming, what is being done, computer-aided programming. And on the right hand side, if you see, these are some of the softwares which are used for mathematical model solving. For example, our computational fluid dynamics, our life cycle, our finite element analysis. And the famous softwares are ANSYS, Hyperwork, MATLAB, Abacus, Console, and Nasrat. So these are some of the applications which are being used. What is concurrent engineering? This concept you must have already heard, but I will rerun over it. So what we do is we usually work in traditional set of engineering system. What used to be done is people used to work in silos. Design engineering used to work alone. Manufacturing engineering used to work on their own. Then the marketing team, sales team, even the project management, they were in silos. But so how it used to happen is research and development used to be done. It used to hand it over to marketing. Marketing used to gather all the information, they used to hand it over to product design. Product design used to hand it over to process design and product integration. All those teams were working in silos. So they were not contacting, you know, with each other on daily basis or whenever there is need. So it was not there. Then what we got to know, or what traditionally people got to know, that okay, we cannot work in silos because let's say when the research and development guy is working on something, process design guy has some idea. Now if he or she throws that idea to R&D department, R&D department can totally change the way they are working. Or let's say they have changed, they have said, they have given all the information to production preparation or production design. Now, if they have some input, the information can flow back again to research and development, and all the things can be restarted again. So that's how it used to work. But now, what happens is they work with each other as a team. No more we work in silos. So R&D, marketing, product, process, production, all the people, all the representatives come together. They discuss what we want to arrive at. There are managers, there are DGMs, all those things will arrive at same place. They will discuss, they will gather monthly reports, they will, see how where we are, do we need any information. We communicate back and forth between all the departments. We flow the information with each other, and that's how we are working parallelly and we are not working in a series manner. And what happens is it reduces the time also to work upon something, and it also gives us a better product. So when you compare your traditional system with concurrent engineering, you get to know that product which has been there in the traditional way and the product which has been got with concurrent engineering is has some major differences and major uh, features. So main important thing about technical review, all those design processes, there are technical reviews at each and every stage. So once, let's say, you have uh, finalized your design and you are sending it to the next level, there is a very detailed technical review which will be done by people in the organization who are the subject matter of expert, and they will give the green light. Until and unless the green light has been given by subject matter experts, it will not move ahead. So why it is necessary to review? So we have to see. So we have to improve the product design to catch a bug or a problem. Is there any problem which has been missed in the previous steps? To help improve both the product and the accompanying documents. Have we missed any documentation? Have we missed to pass any information which is needed to the next level? And also, it can help reduce the product development cost. It minimizes the problems for product users and help to reduce technical support. So if we, identify the problem before we passes to the next stage, we reduces the cost, or we save all the cost for the next level. Also, we minimize the problem occurring within the product. So with the problem or with the less document, if we send it to the next level, we have already generated a huge problem. Then when we go ahead, we have to come back again and then we have to solve it. So that is being not done, and that's why technical reviews are done, so that we can look at all those things. Also, we check whether we are following the company standards or the international standards whenever we are doing something, and that's why the technical reviews are done. The people who do technical reviews are the people within the company, sometimes out of the company, and they may be your teammate, they may be your manager or DGMs. Whoever is a subject matter expert will be involved in the technical review. Now we'll see how a typical organization structure looks like. So on top of everyone, it is the CEO of the company. Even before the CEO, there are board members, there are chairmen, all those things are there. We will not go into that. Then there is a president of a section. For example, engineering section is there, so president of engineering will be there. Marketing president will be there, or head will be there. Then R&D head will be there. Production head will be there. All those heads are there. So president of a section. Then vice president. The vice president is the person who is the next authority, second level authority of president. Then there is regional head. So for a company which is an MNC, there are various regions like South Asia region is there, North America, South America, all those regions are there. So according to regions, people are made head. They look after all the region. Then there is engineering head. Within that region, again there are like engineering heads. There is production head, marketing head, sales head, purchase head. All those heads are there again. So there is engineering head. Within the engineering head, an engineering manager will roll down. Engineering manager and subject matter of expert will be there along with the team. And within the team, there are people like CAD specialist, analysis engineer, design engineer, NPD engineer, material specialist. So those kind of people will be there in the team. So the people are, I mean, the roles are not restricted to these designations only. To just give an overview, I have put certain names. And within these people, some of the people may be uh, the part of the review board. So um, that's how it is being structure of an organization. Typical structure of an organization will look like. And whatever we have discussed, it is all theory. It is just the tip of the iceberg. If you go and have a look at actual industrial setup or actual corporate setup, you will get to know that there is a lot which goes on. Whatever we have discussed, whatever I have told you, it is just the tip of the iceberg. There are a lot more reviews, there are a lot more people involved, there are a lot more departments involved. There is a lot of work which goes on into it before we do uh, any of the next things. So we'll look at a case study of Tata Nano. It is an interesting case study. So, as per Ratan Tata, a journey that symbolizes a human spirit of change, the will to question the unquestionable, the drive to stretch the envelope. So this is his quote for Tata. And where this journey started is he saw a family who was traveling on a two-wheeler in India. There were four members of the family, and he saw that they're traveling, risking their lives, and they're traveling because they cannot afford a car. And at that time, he got to know that whether a conceive a safe, affordable, all-weather form of transport, vehicle which can be affordable, low cost enough to be within everyone's reach. He called he called it a people's car. Now, why Tata Nano was successful? It was built to meet safety standard. It was designed to meet or exceed emission norms. It was very low in pollution and high in efficiency. And this was the dream of Tata Nano. There were people like Osamu Suzuki from Japan. They criticized Ratan Tata that is this product a three-wheeler or a stepney? What is it? Then there are people, he talked about that Tata's 1 lakh car is not feasible and it is not possible. So Tata took it as a challenge and he delivered the car as per his words quote, it is considered as a one-man's dream, and indeed it was, but it took a tremendous amount of teamwork to convert this or translate this into reality. Unquote. So he is telling that it was his dream which started, and then it was a tremendous amount of teamwork, and then they delivered the whole product. The dream came to reality. There was too many critics were criticizing that this is not possible. How can he launch a car and all those sort of things? People wondered that how a nano or a car was launched at sheer price of 1 to 2 lakh. So let us see. There was a stringent review process. There was control measures, post feedback. Cost was a major driver for everything. There are certain material requirements which are defined. Um, Factor of safety was very optimum. It was considered performance was the best thing, and dealing with negative publicity. So there was stringent review process. So each and every step was reviewed by Ratan Tata himself. Cost was a major driver that whatever they are putting into car, they were looking either they are locally they are getting it, or the cost of the material is very low, because each thing will add up, and it will be a huge cost at the end. And there were optimum factor of safety which was considered. Sometimes what happens is we stretch the factor of safety for a product. What I have done for Nano is they have considered the optimum factor of safety. For example, for other products, they were considering 4 and 5 year factor of safety. Here they have considered which is the minimum requirement, that is 2 or 3 year factor of safety. Though that's how it is being done. And for a product, for a car, usually it takes 2 to 3 years at max uh, for development. But for Nano, it was 4 to 5 years development time, and prior to that, 2 to 3 years of background work. So you can see there is a lot of hard work, there is a lot of technical things have gone down, and before we see anything with our naked eyes, we see a Nano on the car, on the road, and people either criticize it or they love it, but we never know what hard work or what amount of things that has gone in the background. Then there is something called as model-based engineering. We will not discuss this in this video. There is a separate video which I am going to make on this subject, and there is a separate video for manufacturing engineering as well. So at that time, we will discuss the topics like what is model-based engineering, what is digital twin. So all those things we will discuss in the upcoming video. This video was intended for people who are freshers, who are preparing for interviews, who have no knowledge of how an industry works or how corporate life is, and people who have very less experience, like 0 to 3 years of experience in the industry sector. For them, this was the video. There are other videos also which are coming up, and there are other videos which are available on the channel. So do watch them as well. Please subscribe to the channel, like the video, comment uh, below the video whatever you feel. If you have any questions, I will be able to happy to solve them. And do share with your friends, family, and colleagues. So thank you. Keep learning, and do watch out for other videos with our channel. Have a great day. Be safe. Thank you.